Today's lesson is 11.7. We're going to add and subtract our radical expressions. Alright, so we're adding and subtracting these radical expressions, that should say radical. And basically what you want to look to see is if the terms you're trying to add together are like terms. So when we throw radicals into the mix, what makes something a like term? So our first example, we have 3 square roots of 5 plus 8 square roots of 5. So if you notice, they both have the square root of 5. That is the thing that makes them a like radical. So it's kind of like saying if you had 3x plus 8x, well, they both have an x, so how many x's do you have? 11x. You're adding your coefficients. So same idea here. If the radicals are the same, so if this is exactly the same, then they are like terms and you can add them together. So your square root of 5 stays the same, and how many of those do you have? You have 3 of those plus 8 of those, so you have 11 square roots of 5. And that is your answer. Alright, the next one, let's see if we have like terms. So it's the radical that tells us if these are like terms that we can put together. So you have a square root of 2x, so that's going to stay the same. And how many square roots of 2x do we have? You have negative 4 plus 9 of those, which gives you a positive 5. So we have 5 of those square roots of 2x. Alright, so even if it starts to look more complicated, all we're focusing on is our radical the same? If it's the same, it's going to stay the same. That's going to stay as a square root of 10xy. And the question is, how many of those do we have? We have 14 of those, and we're subtracting 20 of those. So 14 minus 20 is a negative 6 of those square root of 10xy. Alright, so this next one, we have 3 terms that we're trying to combine, and you want to figure out which ones are like terms. So you've got a square root of 3, a square root of 2, and a square root of 3. So your like terms are the ones that have the same radical. So those you can go together. You have square root of 3. How many do you have? 6 of them minus, now if there's not a number in front, it's like there's a 1, so 6 minus 1 gives you 5 of those square roots of 3, and then plus that 2 square root of 2 doesn't have a like term, so that just stays as its own term. Alright, so of course we're going to have to add or subtract some radicals that are unlike, which means if you look at them, the radical is not the same. So you have the square root of 12 plus the square root of 27. So as is, we cannot add these together. But we know how to reduce radicals. So you want to make sure that your radicals are in the most reduced form or the simplest form, and then see if you have any like terms. So we're going back to the first lesson of the chapter that we learned, how do we reduce our radicals. So 4 fits in 3 times, so this is a 2 square root of 3. Bring down your plus sign. Let's see if we can reduce the square root of 27. That will break down into a 9 and a 3. So that is a 3 square roots of 3. And now if you notice that they're both simplified, they actually are like terms. So how many square roots of 3 do you have? 2 of them plus 3 of them gives you 5 square roots of 3. Alright, so when you're adding or subtracting unlike radicals, you want to, again, just make sure they're in the simplest form. So you can reduce the 8. This breaks down into a 4 and a 2. Square root of 4 is 2. Square root of 2 is 2. But do you see how this one had the 3 out front? So what do you do with the 3? Well, the 3 is still out front, and the 3 is still out front here. So what do you do with the 3 and the 2? This is multiplication. So if you have a number out front, it stays out front and gets multiplied with the one that you can square root. So really we have a 6 square root of 2. Alright, so now let's see if we can reduce the square root of 45. So if you break that down, that's a 9 and 5. Square root of 9 is 3. and the 5 stays, so we're just going to carry this down. The plus comes down, and the 3 square root of 5. Now that everything's simplified, do we have like terms? And in this example, we do not have like terms. So that just means that this is our final answer. We cannot put those together because the square roots are not the same. So they're not like terms. All right, here's our last slide. So we're just going to do 2 more examples. If you notice, these have a couple of variables thrown in. That's okay. Still just focus on, do you have like terms? Are the radicals the same? No, they're not. So let's go ahead and simplify. Now the square root of 28x, first look at the 28. Can we break that down? And that breaks down into a 4 and a 7, which becomes 2 square roots of 7. But remember that 5 does stay out front. We don't want to miss that. Gets multiplied with the 2. So you have 10 square root of 7. We also don't want to forget that we have this x. Now, do we have enough x's to take the square root of? If you remember, you have to have at least an x squared to square root it, so that x just stays in there with the 7. All right, and then if we noticed, our second term here already has that square root of 7x, so we're just going to write that down, minus 8 square root of 7x. So now, do we have like terms? Yes, we do. So we're going to keep the square root of 7x, and how many of those do we have? 10 minus 8 gives us 2. So 2 square roots of 7x. All right, last example, we've got 3 terms. We want to get them all reduced down to simplest form, and then we'll see if any of them can be put together. So let's break down. We have the square root of 125y. First start with the 125. 25 fits in 5 times, so that becomes 5 square root of 5. And then the y, we don't have enough to take a square root, so that just stays as a y. All right, bring down your plus. Now, can we reduce the square root of 20? Well, this breaks down into 4 and 5, which is 2 square roots of 5, but remember that 3 is out front. So 3 times 2 is 6 square root of 5, and again that y is to the first power, so it stays. Minus, can we break down the 45? Well, that's a 9 times 5, which gives you 3 square roots of 5, and there's that y to the first power. So you have 3 square root of 5, the y stays. All right, so I'm just going to do this a second so we can see our problem in simplest form. So do we have any like terms? You've got a square root of 5y, a square root of 5y, a square root of 5y. So we're going to put all 3 of those together. You're going to keep your square root of 5y, and how many of those do you have? You got 5 plus 6, so we're at 11, minus 3 gives us 8. So 8 square roots of 5y. And that's how you add and subtract radicals.